Today we're going to get into algebraic equations and some problem solving. And first we need to translate phrases from English words into an algebraic expression. So 5 less than m. Less than indicates subtraction. So we got m. We want 5 less than m, so m minus 5. I would like you to give B, C, and D a try on your own. I have a feeling you'll get them just fine, but read it, translate it into an algebraic expression, and then we'll check it in 27 seconds. Y decreased by 10 would be y minus 10. The product of 5 and x, product means multiply, so this would be 5x. Quotient means divide. So the quotient of n and 7 is n divided by 7. Another phrase that would mean n divided by 7 would be the ratio of n to 7. So if you see the ratio of and then something to something, that first thing goes on top, the second thing goes on bottom. You do have this page in your notes. This is common geometric formulas. I don't think you really need the square and the rectangle formulas because when it's a four-sided figure like that, you can figure out perimeter, add up all the sides, area, length times width. But here's some common formulas for circles, triangles, and the solids. And the next slide is some other common formulas. There's going between Fahrenheit and Celsius, simple interest, compound interest, and distance. We are going to use the distance formula quite a lot. So D equals RT, that's one that you should kind of have in the back of your head. Example 2 is entirely worked out for you. A cash register contains N nickels and D dimes. Write an expression for the amount of money in cents. So the value of a nickel is 5 cents, and there are N nickels. So if you take 5 times N, that's going to give you how much money you have in nickels. 5 cents per nickel, N nickels. The value of a dime is 10 cents. There are D dimes, so 10D is going to give you the amount of money you have in dimes. So if we combine 5N plus 10D, that's going to tell us how much money we have in nickels and in dimes. Example 3, I don't quite know why the word bicycle is highlighted, but apparently bicycle is an important word. Maybe. A person riding a bicycle travels at a constant rate of 12 miles per hour. I see the word rate. Write an expression. Actually, I'm going to change this to say write an equation showing how far the person can ride in T hours. So how far, that sounds a lot like distance. T hours, that's time, and we've got a rate. So we're going to use distance equals rate times time. How far the person can ride, that would be our distance. What is our rate? 12 miles per hour. And our time is T hours. D equals 12T. So now if I told you that they were going to ride their bike for 3 hours, you could figure out how far they would go. A person paid X dollars plus 6% sales tax for an automobile. Write an expression for the total cost of the automobile. So we're definitely going to pay X dollars plus, it even says the word plus in there, 6% sales tax. We need to change 6% into a decimal. What is 6% as a decimal? 0.06. So 0.06. But it's not just 0.06, because if we buy something that's $10, 6% of that is like, that'd be 60 cents. But if we buy a $1,000 vehicle, the sales tax is going to be a little bit more than 60 cents. So we need to multiply that 0.06 times the cost of the vehicle. What coefficient, what number is in front of this first x? A 1. So if we have 1x plus 0.06x, we could combine that into 1.06x. Basically, you're taking the cost of the vehicle and multiplying it by 106%. You're paying for 100% of the vehicle and 6% more for that sales tax. The sides of a square have lengths of a centimeters. Draw the square. So take a moment, draw a square. I'm going to skip down to the last sentence. Find expressions for the perimeter and area of each figure. They want us to extend this into a rectangle, but ultimately we need to, in the square, find an expression for the area and an expression for the perimeter. So let's do that for the square first. What is the area of this square? Length times width, a times a, which is a squared. And the perimeter? A plus a plus a plus a, 4 a's. 4a. Now let's talk about the rectangle they want us to create. Draw the rectangle obtained by extending two parallel sides of the square 6 centimeters. So now this piece has a length of 6 and it creates a rectangle. The dimensions of that rectangle are, this whole side would be a plus 6. So for the area, length times width, we've got a and we've got a plus 6. So the area would be a times a plus 6. Do you think we should leave it like that, or should we like distribute it? We should probably distribute it. So take a moment and distribute that. So for the area, we end up with a squared plus 6a. And actually, if you go back to how you might have done this in like middle school or elementary school, probably not elementary school, probably middle school. This side of the rectangle has an area of a squared. This side is 6 by a, so it has an area of 6a. You'd add those two areas together. And then the perimeter, which is barely going to fit on my screen. Has anyone figured out the perimeter of this one yet? 4a plus 12. If you're wondering where that came from, if you label everything, even if we take this a plus 6 off, we've got, change pen color, a plus 6 plus a plus 6 plus a plus a. So there are 4 a's being added together, and the 6 and another 6, that makes the 12. 4a plus 12. Your assignment starts on page 73, 12 through 22 evens, 40, 42, 52, and 54.